Hello everyone. Today's video is Chapter 4, and this is Lesson 5. Solve inequalities using addition or subtraction. Now our learning targets for Lesson 5 are to be able to write and solve inequalities using addition or subtraction, and our success criteria states that I can apply the addition and subtraction properties of inequality to produce equivalent inequalities. I can solve inequalities using addition and or subtraction. I can apply inequalities involving addition or subtraction to solve real-life problems. Our key ideas are the addition and subtraction property of inequalities. You can solve inequalities as the same way you solve equations. Use inverse operations to get the variable by itself. So it's important to note here that this is no different than lessons 1, 2, and 3. You're just going to be applying the addition property of equalities as you would have in the past. When you add the same number to each side of an inequality, the inequality remains true. So we just have to make sure that we remember as we're isolating a variable, whatever we do to one side, we do to the other. The opposite of add is subtract. The opposite of subtract is add. And we do not change the inequality, the greater than, less than, or greater than, less, greater than or less than, or equal to signs. We don't change those signs at all. So let's look at our first example. Solve an inequality using addition. You are going to notice that I still draw the line and I still isolate the variable x. The opposite of subtract is add. So I add 5 to both sides. Opposites cancel and I'm left with x is greater than 2, or sorry, x is less than 2. So I put 2 on my graph. My circle is going to be open and my arrow is going to point to the left. So anything less than 2 would be a solution to this inequality. Here we have greater than or equal to. We're going to isolate the z. The opposite of subtract is to add 4.5 to both sides. Opposites cancel, leaving us with z is greater than or equal to. And now we're going to annex in a 0, and we're just going to add. Bring your decimal point straight down. Z is greater than or equal to 7.75. Our circle will be filled in because 7.75 could be a solution or anything greater than. For this example, we're going to draw in our line and we're going to undo the plus 4/5. So we're going to take away 4/5 from both sides. On the right side, those are opposites, so you're just left with g. And on the left side, we have a little bit of extra work to do. We have 7/10 minus 4/5. We need common denominators. So we times that by 2 to get 10. We have to times 4 by 2 to get 8. So this is actually negative 1/10. Now when we graph it, negative 1/10 goes here. Our circle will be open because g is less than negative 1/10. Now it's your turn to try it. Do these 3 on your own, solve and graph showing all of your work, and then push play for the solutions. For question number 1, order of operations in reverse tells us to undo the minus or the plus. So we're going to add 6 to both sides. Opposites cancel, leaving you with y is greater than negative 1. Your circle will be open because it's not equal to. Your arrow will be pointing to the right. Your value is -1. For number 2, we're going to add 3.8 to both sides. Opposites cancel, leaving you with b is less than or equal to. 7 and 5 is 15. 3, 1, and 1 is 5, and you bring your decimal point straight down. 5.5 is our value. Our circle will be filled in because b is less than or equal to 5.5. For number 3, we want to get z by itself, so we're going to add 1/4 to both sides. -1/4 and +1/4 are opposites, so they cancel, leaving us with z. On the left side, we have a little work to do again here. We have -1/2 plus 1/4. We need common denominators, so this is going to be -2/4 plus 1/4, and that is -1/4. So we'll put our point -1/4. Our circle will be open because it's just less than. Z is less than -1/4. In example 2, we will solve an inequality using subtraction. So nothing changes otherwise. It's just we are now subtracting 14 from both sides. Opposites cancel. X is greater than or equal to -1. Circle is filled in. X is greater than or equal to, so the arrow goes to the right. We're going to subtract 7 from both sides. Opposites cancel. G is less than or equal to -4. Circle is filled in. G is less than or equal to. Arrow goes to the left. We're going to take away 6.3. Opposites cancel. We're going to take away 6.3. -9.1 minus 6.3 turns into a chop slash, where we're actually just adding our negatives together. So we get -15.4. Our circle will be open because it's not equal to. D is only less than -15.4, so the arrow goes to the left. Here we're going to subtract 12/5. Plus 12/5 and minus 12/5 are opposites, so those cancel, and we're just left with S is greater than. And on the other side, we're going to take away 12/5. 8/5 minus 12/5 already has a common denominator. So we're just going to take 8 minus 12, so that's -4/5. We'll plot our point. -4/5 is our value. S is greater than but not equal to, so the circle stays open, and the arrow goes to the right. Now you try it. Solve the inequality, graph the solution. For number 4, we'll take away 3 from both sides. Opposites cancel, leaving us with W is less than or equal to -4. -4 is our value on the number line. The circle will be filled in because it's less than or equal to. and the arrow goes to the left. Number 5, we'll take away 10 from both sides. Opposites cancel. Copy your inequality symbol. 8.5 minus 10 is negative 1.5. D is less than or equal to, so the circle's filled in. And because D would be less than, the arrow points to the left. Number 6, we're going to take away 3/4. On the left side, opposites cancel, leaving you with x is greater than. And now on the right side, some of you will probably choose to find a common denominator here. And many of you will choose to convert this into an improper fraction first. 3/2 times 2/2 is 6/4. So then 6/4 minus 3/4 is 3/4. So x is greater than 3/4. Circle will be open because it's not equal to, it's just greater than, and the arrow points to the right. In our first example for story problems, it states, to become an astronaut pilot for NASA, a person can be no taller than 6.25 feet. Your friend is 5 feet 9 inches tall. How much can your friend grow and still meet the requirements? So our current height of our friend is 5 feet 9 inches. So let's write that as 5 feet and 9 inches out of 12. If we simplify this and we divide by 3/3, we'll get 5 3/4. If we take the maximum height of 6.25, that would be 6 25/100ths. And if we divide that by 25/25, we get 6 1/4. So now we have our maximum height and we have our current height, and they both have denominators of 4. So our current height is 5 3/4 plus the amount that we can grow, F, is less than or equal to 6 1/4. So we can take away 5 3/4. Those are opposites, so we're just left with F. And on the right side, we'll take away 5 3/4, and we'll say F is less than or equal to and then 6 1/4 minus 5 3/4 is 1/4. So our friend cannot grow more than 1/4 of an inch. A volcanologist, that's a fancy word for someone who studies volcanoes, rappels, that's a fancy word for climbs on a rope down into a volcano. So a volcanologist rappels 1,200 feet into a volcano. He wants to climb out of the volcano in less than 4 hours. He climbs the first 535 feet in 100 minutes. Graph an inequality that represents the average rate at which he can climb the remaining distance and meet his goal, and also justify your answer. So now when we get started with this one, buckle up. This one's tough. That's why I'm not doing it as a give it a try. Okay, so here's what we know. Graph an inequality that represents average rates. Our rate is going to be feet per minute. Okay, so here's 1,200 feet, or in this case, negative 1,200. And he climbs 535 feet. So he is still 665 feet down. Time, 4 hours. 60 times 4 is 240 minutes. So 60 minutes times 4 hours. And how far has he climbed so far? Climbed 100 minutes so far. What that tells us is 140 minutes to go before he hits that 4-hour mark. We have a rate, 665 feet. That's how much he has left to go in 140 minutes. It's asking us for an average rate. So we're going to have to divide because this is a division problem. So we would say 665 divided by 140. How many times does 140 go into 665? There's 2, and we're at 280. Add another 140. So then 8 plus 4 is 12. So we're at 420. 420 after 3 times. Let's add another 140. So after 4 times, we're now at 560. And if we were to add another 140, that would put us at 700. So we know that's too much, right? So we know 140 goes into 665 4 times. 4 times 140 is 560. We have 105 left over. $105 is what's left over. That's your part that's left. Your whole is still the 140 minutes. And from here, we're just going to simplify this. Let's divide by 5 over 5. Get 21 over 28. That simplifies. You can divide by 7 over 7. 3/4. 3/4 could be written as 0.75. So now we have 4.75 feet per minute. And we have to write and graph this as an inequality. X would have to be greater than 4.75 feet per minute in order for this volcanologist to be able to climb out in less than 4 hours. So our graph would be 4.75. Our circle would be open, and our arrow would be pointing to the right. Now to conclude, here is one that is a little bit easier for you to try on your own. You install a mailbox by burying a post as shown. According to Postal Service guidelines, the bottom of the box must be at least 41 inches, but no more than 45 inches above the road. Write and interpret two inequalities that describe the possible lengths of the post. Once you've completed this, push play and I'll talk you through it. So what we know is that the post is buried 24 inches deep. We're trying to find possible lengths of the post that we need to buy. The bottom of the post must be at least 41 inches. The bottom of the box. It must be at least 41 inches. And at most, it could be 45. So here's what we can think now. If we take the 24 inches that the post is buried and we add the 41, that's going to give us our minimum. Our minimum would be 41 plus 24, which is 65. So we could say X has to be bigger than or equal to 65. And in words, our post is at least 65 inches. Now we have 24 inches and it could be as much as 45. So our max could be the 45 plus 24, which would be 69. And X has to be less than, or it could be equal to 69. And in words, our post is at most 69 inches.